This is the third video on piecewise functions, and we are going to graph a function given its equation. First, I need to know which areas of the graphing paper I will be graphing at. These are indicated by the intervals for x. The first interval is x is less than or equal to -4, which is the left part of the graphing plane. The next interval is x between -4 and 2, which is the middle part of the graphing plane. And the last interval is x greater than 2, which is the right part of the graphing plane. So in the left I will be graphing y equals 2x plus 6. In the middle I will be graphing y equals to -2. And in the right I will be graphing y equals to 1.5x minus 6. To graph the line y equals to x plus 6, I'm gonna start at the y-intercept 0, 6, and I'm gonna rise 2 and run 1. So starting at 6, if I rise 2 and run 1, this is my next point, but I really need to go towards the left. So I'm going to rise -2 and run -1, and I will keep repeating the slope movement until I can get some points on the left. From all of these points, all the points I drew in the middle interval are not going to be needed since I'm only graphing y equals to x plus 6 on the left. So I'm going to start at the point -4, -2, and I'm going to graph my line towards the left with an arrow indicating that it goes to -infinity. Because x is less than or equal to -4, the point -4, -2 is a closed point in this graph, and it belongs on the red graph that I have indicated. My next task is to graph the line y equals to -2. This is a horizontal line. It has a y-intercept of 0 with -2 and slope 0. So I'm gonna go to its y-intercept and I'm gonna graph a horizontal line only in the middle interval without extending it to the left and to the right. So it's actually a line segment. I need to identify if the left endpoint and the right endpoint belong on the graph. The left endpoint is an open circle, but because it happens to coincide with the endpoint of the other branch we have already drawn and it was closed, I don't need to bother making it open since it is included in the overall graph of the function anyways. So I'm only going to check the right endpoint. It says x less than or equal to 0, so that endpoint is closed. The next part of my graph is to graph the equation y equals 1.5x minus 6. I like to have the slope as a fraction. This is the same as 3 over 2x minus 6. So it has a y-intercept of 0 with -6 and a slope with rise 3 and run 2. So if I go to the point 0, -6, and I rise 3 and I run 2, and I rise 3 and I run 2, and I keep the pattern of the slope, I now get a bunch of points that belong on my line, but the point that is in the middle interval is not of interest to me since I'm graphing only on the right interval. So I'm going to start at the point 2 with -3, and I'm going to draw my line towards infinity. Now I need to know if the starting point is going to be open or closed. The inequality x greater than 2 indicates that it is open, so I'm going to draw an open circle. If I remove my visual aids, the graph of the function is shown.